Alright, so this is section 5.4. So we're going to look at the trig functions defined on the unit circle. So before we jump into this section, I'm going to review a couple of things. The first is reminding you of what a unit circle is. So if you recall, a unit circle is a circle that's centered at the origin with radius of 1. Right? So I can draw a picture of this. Let me get some graph paper. Oops. Yeah, there we go. Get some graph paper here. So just make an x-axis. Make a y-axis. And let's say my interval goes up by a fourth. Right, so it takes 4 tick marks to be to make one unit, right? So then these points that I'm drawing, so this will be the center of my circle, right? The center's at the origin, 0, 0. And the radius of a circle is 1, right? So this would be 1 unit. This would be 1 unit, so forth. So I'm going to have dots at these points. And then let me see if I can make a circle here. There. So then if I draw a line from the center just to any random point, right? The radius of the circle is 1, so that distance is also going to be 1, right? So that's what we mean by a unit circle. So this circle is a collection of all points that have a distance of 1 from the center, right? So then the next thing I want to remind us of is what's the equation for a unit circle, right? So if you recall, in general, the equation of a circle is the following: x minus h quantity squared plus y minus k quantity squared equals r squared, the radius squared. So you should have learned this in college algebra, right? So hk is the center, r is the radius, right? So thinking about this, in terms of the unit circle, so the unit circle, hk is going to equal the origin, right? The center is at the origin, so we get 0, 0. So in other words, h equals 0 and k equals 0. And then the radius is 1, right? So r equals 1. So if I plug in 0 here and here and 1 here, what I'll get is just x squared plus y squared equals 1, right? Because it'd be 1 squared, right? Because x minus 0 is just x, so that's why we get x squared here, right? Similarly here, we'd have y minus 0 squared equals just y squared, and then 1 squared is 1, right? And if you don't see that, I can just write this out for you really quick. Right? So this was 0, this was 0, this was 1, plugging those values in. So then we'd have x minus 0 squared plus y minus 0 quantity squared equals 1 squared. So as I said, this would reduce down just to be x squared. So x minus 0 is x, y minus 0 is y, and 1 squared is 1. Right? So then here I could just write this now as x squared plus y squared equals 1. Right? So those are going to be some important items to help us with defining the trig functions on the unit circle. Right? So then I have over here an example just using this equation. It's similar to question number 1 on your homework. So I have the point P is on the unit circle. Find the y-coordinate of P if the x-coordinate is 5/8 and P is above the x-axis. Right? So if we go to my picture, come on, there. Let me get rid of this blue line. Right? So essentially, what we have is we have some point P that's above the x-axis, so somewhere up here, right? And the x-coordinate is 5/8, right? So this would be, a half. 5/8 is going to be a little bit bigger, right? So if I look at, let's say this is x equals 5/8. I'm just drawing these dash lines, right? Then both of these blue dots that I had placed on the unit circle both have an x-coordinate of 5/8. That's so the criteria that the point P is above the x-axis, right, throws out this option, right? That's not a possibility, and our attention focuses on this one, right? This point, right? So we're just going to get one, be able to get one solution. So, and so then what we know about this point is that the x-coordinate is 5/8 and the y-coordinate is question mark, right? That's what we're trying to find. That's the goal, is to find that y-coordinate. So, we have this equation, x squared plus y squared equals 1. This is a relationship for all the points on the circle. So I can just plug in 5/8 in for x, leave y, and then we're going to end up solving for y, right? So 5/8 quantity squared would be, 5 squared over 8 squared plus y squared equals 1, right? So don't forget your exponent rules, right? If I have like a divided by b to the nth power, that's a to the n over b to the n, right? So that's just an exponent rule. So this gives me 25 over 64 plus y squared equals 1. So we're going to have to subtract 25 over 64 from both sides. So I get y squared equals, so 1 I could rewrite as 64 over 64, right, to get a common denominator. So we'd have 64 over 64 minus 25 over 64. So then, if you take, subtract those, we take 64 minus 25, and we get 39, right? So this would end up becoming y squared equals 39 over 64. So then I would take the square root of both sides, right? And typically I'd put a plus or minus on this side, right? But one thing we know, like from looking at the diagram, right, since we're above the x-axis, that tells me that y has to be positive, right? Because down here, this would be when y is negative, this point that we threw out. So we don't have to put the plus or minus in here, right? So then the square root of y squared is just y. And then here, if you have the square root of a divided by b, this is equal to the square root of a divided by the square root of b, right? We can use that to help reduce this down. So I would have radical 39 over radical 64, which equals, so radical 39, I can't simplify, but radical 64 is 8. right? So the y coordinate ends up being radical 39 over 8. Right? And I know I can't simplify that down, right? Because 39, the prime factorization of that is 3 times 13, which both of those numbers are prime, right? So I can't pull out a perfect square out of there. Right? So that's just an example. Right, so you want to be comfortable with that. So I have another example here. Before we get to there, I first need to fill this blank part out for ejecta 1. So we want to be able to, define, use the unit circle definition of our trig functions, right? So let me show you where these come from, and I'll write these down at the bottom. So basically what we're going to say, so we need to make some assumptions here. So we're going to say let point P, which has the coordinates x comma y, be the point associated with a real number t measured along the circumference of the unit circle from the point 1, 0. So essentially what we're doing is we're wrapping, so wrap a number line basically the t-axis, right, around the circumference of the circle with, so if you're going this direction, right, we're going counterclockwise, right, that would be a positive direction, and if you're going this direction, that would be negative, right? So consistent with measuring a central angle that we had talked about, right? All right, so that's the word setup. Let me draw on here for you a few things, so this is making some sense. So I'm just going to get rid of some things we had written on this unit circle. Oops. All right, so essentially what's going on is we have this unit circle, right, xy, and what we need is we need this t-axis, right? So here's another t-axis, right, which just is a number line. So somewhere there's going to be 0, 1, 2, -1, -2, and so forth. So we have this this t-axis, and what I want to do, so the statement where I'm saying it's measuring the distance from the point 1, 0. So this is kind of like my measuring tape, if you will, right? So essentially, this pink dot here at 0, we're going to put at the point 1, 0. And we want this direction to be positive and this direction to be negative, right? So we're taking this number line, kind of think of like a, measuring tape that's flexible, right? And we're just going to put the t-axis over here, right? So we're taking this part here and putting it here where I drew this pink, right? So here would be, like 1, 2, 3, and so forth. And then Let me grab a different color. Right, so maybe this orange. Oops, I thought I clicked orange. All right, so I'll just do this dark yellow. All right, so essentially this part of the graph is going to be here. Right, so this would be, -1, -2, -3, and so forth. Right, so that's essentially what that whole paragraph is introducing. Right, we have the unit circle. We just have this t-axis on here. Right, so then let me write a couple more things. So let me draw this diagram in. Okay, so here's a unit circle. So remember that like if here is this point P, which is x comma y, right? Then we can draw like a ray through that point. In this angle, right, we could say let be theta, right? And this point, if this is a unit circle, would be the point 1, 0, like we talked about. And then this distance here would be t, right? Was the t-axis we just introduced, right? So one thing that we need to think about or recall, so let's recall that theta is equal to s, the arc length, divided by r, right? We talked about this. So since we're in the unit circle, one thing we know is that r is going to be equal to 1, right, in a unit circle. So if we plug that in, what we're going to get is that theta is equal to s divided by 1, which is equal to s. Right? So just some things to note is that arc length should be greater than or equal to 0, right? It's a distance. Same with radius. Radius is a distance. So the radius should actually be greater than 0, because if r was equal to 0, then we wouldn't have a circle, right? So that's just something to note. So the arc length could be equal to 0, though, right? Like if we look at the measure of 0 degrees, right? So then, if we think about this logically, there's really two cases that can occur, right? So one case is when t is positive, so and we'll just include the 0 case in with the positive case. So if t is greater than or equal to 0, right? Well, what we know about theta is that theta will also be greater than or equal to 0, right? And the whole idea with this, right, because on this diagram, right, if t is positive, right, that means we're going in this direction, right? We're just measuring this on the x-axis, right? So if we're going in a counterclockwise motion, right, then that means that theta is going to be greater than or equal to 0 as well, right, because we're going in that direction. Right, so then the second case that can occur is when t is negative, as you could guess, and when t is less than 0, t is negative, then theta would also be negative, right? Same idea, because you're going in a clockwise motion, right? So let's look at case 1. So I'm just going to draw like a generic picture here. So we have, this central angle with a point P on it, right? Where a point P is on the unit circle, right? So this is the unit circle. Then, this part is going to be theta. And then, along this part, that's going to be equal to t, right? So what we can say here is that the arc length, right, which would be this part that we shown in red, right, on the diagram, that's going to be equal to t, right? But it's also equal to s because that's the variable that we use for the arc length, right? So this t value is going to be equal to the arc length, right? So what we would have is, well, we know that r equals 1, right? That's something that we know because it's a unit circle. We also know that s equals r times theta, right? So if we plug in some of these unknowns, what we end up with, so replace t with s, we get t equals, and then if we replace 1 for r, we get 1 times theta, right? So then what we end up with is that t equals theta, right? So then let's look at case 2 now, right? So similarly, let's just draw a picture to kind of help us visualize this. So here's a unit circle. I'm going to draw just a random point here. Let's just say in the third quadrant. Right, so again, we'll just keep it consistently, let that be point P. So this part would be theta, and because theta is negative, right? So we got to go to clockwise, and then this distance here, right, from this point 1, 0. Remember, we let that be t, right? So in this case, my arc length would still be equal to s, but arc length is always positive, right? So in this case, t is negative, so I'm going to have to put a negative side in front of t in order to make it positive, right? So s would have to be negative t, right? So if like t is -3, then this negative, so negative 3 will make it positive then, positive 3, right? That's what we want to happen for arc length, because that should always be positive, right? So we just put the negative in front, and that would be equal to the arc length, right? R is still equal to 1, right? We're still in the unit circle. So a similar idea, if we plug in what we know, we have s equals r theta. So if we plug in our unknowns, I would have s equals r also, since theta is negative here, we want to put a negative theta here, right? So that way it keeps everything balanced out, right? We assume that theta is a positive angle in that equation. So then, plugging in our unknowns, we plug in negative t in for s, so we'd have negative t equals, the radius is 1, so we plug in 1 there, and then we'd have times negative theta, right? So then what we get is that negative t equals negative theta, so I can multiply both sides by -1, and we get t equals theta, right? So what we've done and kind of played around with is we've realized that no matter if t is positive, negative, or 0, the situation that we have is that t is always going to be equal to theta, right? So that's going to be helpful to us, right? All right, so let me make some room here off to the side. So I want to write out these 6 trig functions. Right? So in other words, what we can say is that, with what our work we just did over here, we can say that so t equals theta, right? So no matter what, t is going to be equal to theta. So since t is equal to theta, then sine of theta, right, we looked at last time, is equal to y over r. Right, so in this case, the radius is 1, so we'd have y over 1, which is equal to y. And this would be the same thing as sine t, right, since theta equals t. So in other words, sine theta equals sine t, which equals y. Right? And if you're having trouble, maybe visualizing how we came up with this part, I can show you here. So let me show you here. All right, so here, here we have a unit circle, so we'll let, this be 1, 1, negative 1, negative 1. So if I draw, this random point here, point P, which is x comma y, right? Recall that, if I draw this ray that's going through this point P, this is, theta. Then if I make a right triangle here, right, then this distance is going to be x. This distance is going to be y, equivalent to y. So really it would be, the absolute value of x, the distance, right? And then this distance is equal to r, right? So we looked at this previously, but just to recall that, so the hypotenuse is equal to r. So when we talk about, like sine theta, this is equal to the opposite over the hypotenuse, right? Which in this case would be equal to y divided by r, right? So we looked at all of those before. Right, so just recall that's what we're doing. So then if I look at some others, like, let's say we want cosine of theta. So cosine of theta, if you remember, is x divided by r. But again, remember that r is 1 in this case, so this would be x divided by 1, which is just equal to x, right? Which would be the same thing as cosine of t, right? Because again, theta is equal to t, right? That's what we concluded here. So then basically what we'd have is that cosine of theta equals cosine of t, which is equal to x, right? So what I'm putting in the boxes are is what's important to remember, right? So then tangent of theta would be equal to y over x, if you remember, right? Which would be the same thing as tangent of t, right? Since theta equals t. Something important to note here is that x cannot equal 0, right? Because x is in the denominator and we can't divide by 0, right? So then we can easily come up with the reciprocal functions, right? So, for sine, remember cosecant is the reciprocal of sine. So cosecant of theta equals cosecant of t, which would be equal to, so the flip, it would end up being 1 over y, right? Where, of course, y cannot equal 0 here, right? Since y is in the denominator. And then here, remember, the reciprocal function of cosine is secant. So this would be secant theta equals secant t, which would be equal to 1 over x, right? The reciprocal. So that would be that x, and also note that x cannot equal 0 here. Same rationale as before. We have x in the denominator, so we can't let that be equal to 0, right? And then lastly, for tangent, we would have cotangent. So we'd have cotangent of theta equals cotangent of t, which is equal to the inverse, multiplicative inverse, so that'd be x over y. And in this case, y cannot be equal to 0 since y is on the bottom in the denominator, right? So that's how we define those 6 trigonometric functions, but using the unit circle. Right, so just to reiterate another fact, so we have trigonometric functions of real numbers and angles, right? So what we can say is that if theta equals t, right, if we have that situation, t radians, then what we can say is that sine of t equals sine theta. Cosecant of t equals cosecant of theta. Cosine of t is the same thing as cosine theta. Secant t equals secant theta. Tangent of t equals tangent of theta. And cotangent of t equals cotangent theta. Right, so just reiterating that. So now let's try example using some of this, what we just learned. So then we're just defining this on unit circle. So example 1 is to suppose that the real number t corresponds to the point radical 5/5 and 2 radical 5/5 on the unit circle. Evaluate the 6 trigonometric functions of t, right? So, oops, let me get rid of that. So knowing that this is my point P, right? So if I just draw, an XY plane, draw my unit circle on here, then since this X coordinate is positive, this Y coordinate is also positive, I know I'm going to have my point P is going to be somewhere in the first quadrant, right? So I'll just draw a generic point here. So this point is point P, which is radical 5 over 2, comma 2 radical 5 over 2. Right? So this guy, this is going to be some unit theta, and this distance here between the point 1 comma 0 and point P, remember we're letting that be equivalent to t. Right? So if I zoom in here, if I draw I make this into a right triangle here, and I pull this apart, right, then this angle is going to be, theta, right, which remember is the same thing as t, right? We said theta equals t. Then this part here is going to be the x coordinate, which is radical 5 over 5. And this part here is 2 radical 5 over 5, right, the y coordinate. And this part of the hypotenuse of this is equal to 1, right? And I know that's equal to 1 because we're on a unit circle, right? The radius is 1. So this guy is 1 here, right? So this is the triangle we want to be thinking of, and we're focused in on this angle here, right? So now we just need to find the 6 trigonometric functions. So, sine of t, there's a couple of ways to think about it, right? We just defined sine of t to be equal to the y coordinate. You could do that, or you could do opposite over hypotenuse, right? So you would have, 2 radical 5 over 5 all over 1, which is just equal to 2 radical 5 over 5, which is, of course, equal to the y coordinate, right? So there's what sine's equal to. Cosine of t is just equal to the x coordinate, right? So that would just be radical 5 over 5. Tangent of t is equal to y over x, which would be equal to 2 radical 5 over 5 divided by radical 5 over 5. So we could clean this up, right? We're dividing fractions, so this would be 2 radical 5 over 5 times the reciprocal of the denominator, which would be 5 over radical 5, right? So then, the radical 5s can cancel, the 5s can cancel. We're just left with, it would be 2 over 1, which is just 2, right? So then, now we need to find the other 3 trig functions. So since tangent of t is just 2, cotangent of t would be probably the next easiest to find, right? And that would just be 1/2, right? It would just be the reciprocal. So then the other 2, right? So we need to find cosecant of t. So cosecant of t would be 1 divided by sine of t, which would be equal to 5 over 2 radical 5, right? It'd be the reciprocal. So then I need to multiply top and bottom by radical 5 in order to rationalize the denominator. So we'd have 5 radical 5 in the top and 2 times 5 in the denominator. So that would give me, so the 5s can cancel, right? So then what we're left with is just radical 5 over 2. Right, so that's cosecant. And then lastly, we need to find secant of t, which is 1 over cosine of t. Right, so we would just take them, the reciprocal of cosine, which would be 5 over radical 5. So we need to rationalize the denominator. So I get 5 radical 5 over, so radical 5 times radical 5 is just 5. So then similarly, the 5s are going to cancel. We're left with radical 5 over 1, which is just radical 5. Right? So there's all 6 trigonometric functions of t. Right? So then objective 2 is to evaluate the trigonometric functions using the unit circle. So we need to just review real quickly some special right triangles that we had learned in a previous video. So one of them is a 30-degree, 60, 90 right triangle. Remember, the hypotenuse is 2, the angle, the side length across from 30 degrees is 1, and then the other leg is radical 3, right? So one thing we can do is we can multiply all the sides by 1/2, right? We're like scaling it down, right? What this will give me, so the angles would stay the same, and these would be similar triangles, right? So 2 times 1/2 is 1, 1 times 1/2 is 1/2, and radical 3 times 1/2 is radical 3 over 2, right? And the reason why I did this is because on the unit circle, we want the hypotenuse to be 1, right? Because that's what it is. So that's why we're scaling that down. So then if I use my other special triangle, which is the 45, 90, right? This is 2, this is radical 2, and this is radical 2. Then similarly, let's multiply, scale this down by a factor of 1/2. So that way, my hypotenuse is 1, right? Because we're in a unit circle. So radical 2 times 1/2 is radical 2 over 2. And that would be the same thing for both of these sides, right? So then the situation that we are going to have is if I have, a unit circle where this degree here is 30 degrees, right? This is going to be 1, this is 1/2, and this is radical 3 over 2, right? Just pulling that from the triangle that we just worked with, right? So then if I want to figure out what this point P is, right, it's going to be my x-coordinate, which is going to be this guy, radical 3 over 2, and then comma y, which is the 1/2, right? So we can find the coordinates for point P of a 30, 60, 90 right triangle, right? So we can repeat this process, right? So actually with the 30, 60, 90 triangle, I could draw another scenario using that triangle, but maybe let this angle be 60 degrees, right, instead of 30. So we're still going to have some point P here. We need to figure out the xy coordinate. So this would come down. Across from 60 now would be radical 3 over 2. This would be 1, and this would be 1/2. So notice the x and y coordinates just swap spots, right? So the x coordinate would be 1/2. The y coordinate is radical 3 over 2, right? And then lastly, the other scenario that we could draw with this, if we're trying to keep everything in the first quadrant with these triangles, is if this was 45 degrees, right? So if this were 45 degrees, then on my triangle, this would be 1, right? Because we're in a unit circle. This would be radical 2 over 2, radical 2 over 2. So this point, coordinates of point P, then would be radical 2 over 2, comma, radical 2 over 2. Right? So using that idea, we can fill in what's known as the unit circle, right? So you'll notice in part of the unit circle is we're filling in the degrees, the radians, and also what trig functions are positive and negative in each quadrant, right? So let's try to fill this in. So, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And remember, something that helps us with the sign is, all students take calculus, right? So what's going to be positive in the first quadrant is going to be sine, cosine, tangent, cosecant, secant, and cotangent, right? All 6 trig functions are going to be positive, and there are none that are negative, right? And then in the first quadrant, right, the S stands for sine, so sine is going to be positive, and also its reciprocal function cosecant is also going to be positive in the first quadrant. So then all the others are negative, right? So cosine, tangent, secant, and cotangent. And then so down here, remember the t reminds me that tangent is positive. So tangent is positive in the third quadrant, and also cotangent. So then all the others are negative, so sine, cosine, secant, and cosecant. Then lastly, the fourth quadrant, the C for calculus, reminds me that cosine is positive, which means its reciprocal function secant is also positive, right? Because if you have a fraction like 1/2, if you find the reciprocal of that, it's going to stick with the same sign, right? So then all the other four trig functions are going to be negative, which is sine, cosecant, tangent, and cotangent. Right, so we got that part filled in. So now what I could fill in are the degrees, right? So this would be like 0 degrees, 0 radians, right? Also, this would be, 360 degrees or 2 pi radians. And this is the 0.10, right? Over here, this is the 0.01, right? This would be, 90 degrees. Or pi over 2 radians. This point here we could fill in -10, right? This would be pi radians or 180 degrees. Let's see. And then down here would be the next easiest one to fill in, right? 0, -1 would be that coordinate of that point. This would be at 270 degrees or 3 pi over 2. Right. So we got maybe some of the easiest filled in. So now what we want to do are use, the reason why we went over this is we want to use these three scenarios on the unit circle, right, to fill everything in, right? So either, having a 30, 60, or 90 degree, or 30, 60, or 45 degree reference angle, right? Essentially what we're doing. So if this is 30 degrees, right, that means this is 30 degrees. And 30 degrees, if you remember, corresponds with pi over 6 radians. So, using, this here, this is what we would have. We would have radical 3 over 2 1/2 for the coordinates. So this would be radical 3 over 2 1/2 for the coordinates, right? We already did that work. So then kind of the next angle here, right, would be, 45 degrees. So if this is 45 degrees, remember that corresponds with pi over 4 for radians. So the x and y coordinate for that point, would be looking at this guy here, right, which is radical 2 over 2, radical 2 over 2, right? And then the next, degree that could be here, this angle, this would be 60 degrees, which that corresponds with pi over 3 radians. And the x coordinate for that was 1/2 and radical 3 over 2. Right? So then now it's just a matter of filling in the other degrees, right? So like in the second quadrant, this is going to be 30 degrees, the reference angle. This guy is going to be 45 degrees. And then from here to here, that's going to be 60 degrees. Right, so just doing some basic subtraction, right? We could figure out all of these degrees, like, to figure out this answer here, right? We would just need to take 180 minus 30, right, which would be 160 degrees. And then to find the next spot up, we would take 180 minus 45, which is 135 degrees. Right, oops, excuse me. Should be 150 for this, sorry. 180 minus 30 is 150, right? And then the next one, we would take 180 minus 60 and get 120 degrees, right? So we can fill those spots in accordingly using those reference angles. So then if you convert these into radians, so remember what we'd want to do is take the degrees and multiply it by pi over 180 degrees to put us into radians, right? So you could do that for each of these. What you end up getting is that this is 2 pi over 3. 135 degrees is 3 pi over 4. 150 degrees corresponds with 5 pi over 6, right? And then, so these ordered pairs are just going to follow, like kind of like a mirror image, right? So this ordered pair is just going to come over here and essentially be the same, right? The only thing that'll be different are the signs. So when you're in the second quadrant, the y coordinate would be the same as in the first quadrant. But what would be different is the x value is negative, right? Because you went to the left. So then, this point would just come over here, right? Kind of just falls over. So this would be negative radical 2 though over 2, since it's the x coordinates over here are negative. And then it would be positive radical 2 over 2 in the y. And then this would be negative 1/2, and then radical 3 over 2 for the y coordinate, right? So we're just pulling that over. And again, the difference here is that the x coordinate would be negative because we're to the left of the origin. Right, so then we can keep filling all these in, right? So like, this here would be 30 degrees, and then this reference angle would be 45 degrees, and then this reference angle would be 60 degrees, right? We just have to think about, in this case, you would have 180 plus 30 degrees, right? Which would get me to 210 here. And then we would have 180 plus 45 would give me 225. And then 180 plus 60 would get me at 240 degrees. And then we can convert each of those into radians. So that would be 7 pi over 6. 225 degrees would be 5 pi over 4. And 240 degrees is 4 pi over 3. Right? So, this would be radical 3 over 2, 1/2. Radical 2 over 2, radical 2 over 2, and 1/2 radical 3 over 2, right? Just writing down those corresponding points as before, right? But in this case, in the third quadrant, remember the x and the y coordinates are both negative, right? So we would just have to put a negative sign in front of these. Right. So notice how we build the first quadrant. All the other quadrants just kind of follow suit, right? So then, how do I find this first one? This reference angle would be 30 degrees. This would be 45 degrees. And this would be 60 degrees. Right, so 360 minus 30 degrees is 330, so that's here. And then 360 degrees minus 45 is 315 degrees. And then 360 minus 60 degrees is 300 degrees. Then converting each of those into radians, we would have 11 pi over 6 here. Here would be 7 pi over 4, and then 5 pi over 3. Right? And then, the reference angle corresponding to 30, that's radical 3 over 2, comma 1/2. The point for reference angle of pi over 4 is radical 2 over 2, comma radical 2 over 2. And then for 60 degrees, the coordinate is 1/2 radical 3 over 2. Right? So in the fourth quadrant, the x values would be positive, but the y coordinates are negative, right? So I just need to put a negative sign in front of the y coordinates. And then I have finally filled in this unit circle, right? So this unit circle will come in handy that we can use as a reference tool in this class, right? So you maybe heard of the unit circle before, and that's what we use in trig, right? So then now what we're asked to do is evaluate the 6 trigonometric functions of the real number t, right? So part A, we have t equals 5 pi over 6, right? So if we look back at the unit circle, we're looking for 5 pi over 6, and we get this here, right? So we can write that down, that t equals 5 pi over 6. That corresponds to the point negative radical 3 over 2 comma 1/2, right, on the unit circle. So we can use that information. Let's see, that's a 3, radical 3. We can use this information to find all the trigonometric functions of this, right? So for example, we know that sine of 5 pi over 6 is going to be equal to the y coordinate, right, from before. So that's pretty easy, right? And that's just a half. We just copy paste, right? Cosine of 5 pi over 6 is equal to the x coordinate, which is negative radical 3 over 2. Tangent of 5 pi over 6 is equal to y over x, which would be 1/2 over negative radical 3 over 2, which, so we're dividing fractions. This would be, 1/2 times 2 over negative radical 3. So these 2's cancel. What we end up with is 1 divided by negative radical 3. So I need to divide multiply top and bottom by radical 3 to rationalize the denominator. So I get radical 3 over 3, and it's negative, right? So negative radical 3 over 3 is equal to tangent. So then now to find the others, right, we just be multiplicative inverses. So, cosecant of 5 pi over 6 is, is going to be equal to 1 over y, which is 2. Right, just interchange the 1 and 2. So multiplicative inverse of 1/2 is 2. So then secant of 5 pi over 6 would be equal to, well, that's what, 1 divided by cosine of 5 pi over 6. Right, which would be equal to 1 divided by negative radical 3 over 2, which would be negative 2 over radical 3. So I need to rationalize the denominator, which gets me negative 2 radical 3 over 3. Right. So then the last one we need to do is cotangent. Cotangent of 5 pi over 6 is equal to 1 divided by tangent of 5 pi over 6, right? The multiplicative inverse of tangent. So that would be, so what I would do, right, is just focus in on this guy, right? Because that's what tangent's equal to. But if we flip that, the nice thing about it is it's easy to reduce. We don't have to rationalize the denominator. So this would give me just negative radical 3, right? So there's all of those. Let's see how we're doing on time. All right, so we're about an hour in. All right, so I think what I'll do is I'll split this into 2 videos. Let me finish this next example, and then we'll call it a day for this video. Right. So just so you can see this, this is t equals negative 3 pi over 4. right? So if I add 2 pi to this, right, that would be negative 3 pi over 4 plus we want 4 to be on the bottom, so this would be what, 8 pi over 4 would be equal to 2 pi. And if we add those together, we end up with 5 pi over 4. Right, so those two, these are coterminal, right? So 5 pi over 4 is coterminal to negative 3 pi over 4. So it just makes it a little easier to work with, right? So then if we look on the unit circle, we're looking for 5 pi over 4, which is here. Right, it's equivalent to 225 degrees. So what we want to do is note that so we could say that negative 3 pi over 4 is co-terminal with 5 pi over 4. 5 pi over 4 corresponds to the point P, negative radical 2 over 2, comma, negative radical 2 over 2. So this, this is from the unit circle. So then, sine of negative 3 pi over 4 is going to be equal to the y coordinate, which is negative radical 2 over 2. Cosine of negative 3 pi over 4 is equal to the x coordinate, which is negative radical 2 over 2. Tangent of negative 3 pi over 4 is going to be equal to y over x, which is negative radical 2 over 2 divided by negative radical 2 over 2. So notice I have the same thing in numerator and denominator. So if I take the same number divided by the same number, I get just 1. Right? So that means that cotangent of negative 3 pi over 4 is also equal to 1, right? Because the multiplicative inverse of 1 is just 1, right? So then we need cosecant of negative 3 pi over 4 yet, which would be equal to 1 over y, which is equal to 1 divided by negative radical 2 over 2, which I need to, I'll need to flip that, right? So that would be equal to negative 2 over radical 2. I need to rationalize the denominator, which gives me negative 2 radical 2 over 2. So the 2's cancel. We're left with just negative radical 2. Right. So then lastly, we need to do secant of negative 3 pi over 4. This would be 1 divided by x, right, which would be 1 divided by negative radical 2 over 2. And this is just going to follow the same work, starting here. So this is just going to equal negative radical 2, right? Same work as from above. So now we have all of those trigonometric functions found for the given t value, right? All right, so this will wrap up the first part of this section. I'll make a second video for this section. Just let me know if you have any questions. Thanks.